In this presentation, I'll be discussing how to throw a frisbee, the generalized motor program, and the biomechanics behind the perfect pitch. So what is a generalized motor program? Well, it's a combination of multiple different movements that are used to perform a task. There are multiple different parts to a generalized motor program, and as I go through this presentation, I'll explain each individual component that makes a generalized motor program a generalized motor program. First, I'm going to go over all the invariant features, which are features that cannot be changed. First and most importantly is the sequence of actions. So let's discuss the basics on how to throw a frisbee. As you can see, I provide you with examples. Now that you have your frisbee, put your palm on the side, your thumb on the top, your index finger on the curvature, and then the remaining fingers should be underneath the lip. So as you can see in the example I provide above, I'm 90 degrees with where I want to throw the frisbee, with my right foot being my dominant foot, which is pointing towards my target, and my left foot pointing away from my body at a 90-degree angle. So as you can see, I'm pulling my arm back towards my body with my arm and elbow parallel to the ground. Then I'm bending my wrist back in preparation to throw the frisbee. Now it's time to throw your frisbee. This, as you can see in the example I provided, means straightening your arm until it's nearly fully extended and then flicking your wrist to release the frisbee. As you can see, it takes a lot of practice to get good at throwing a frisbee where you want it to go. And it takes players thousands of times to finesse their throwings. To determine whether a generalized motor program is indeed a generalized motor program is to rewind the video to see the movements in reverse. If the movements don't constitute a throw, then you know it's a generalized motor program. And as you can see, if you were to play this video in reverse, it would indeed not result in a throw. Important component and invariant feature of a generalized motor program is the relative timing. This is the breakdown of timing for each component in the entire skill. The timing of these components does not change drastically between players or due to the amount of times a frisbee has been thrown. The example I provided from the study by Monthubert and Sarah Hummel shows the relative timing of each joint activation and muscle activation required for throwing a frisbee. As you can see, this is an average, which means that the relative timing does not change drastically based on the player or based on the amount of times the frisbee has been thrown. The figure in the bottom right-hand corner is a representation of a player and their joint angles at the very start of the generalized motor program. The final invariant feature I'm going to discuss is relative force, which can be explained as the ratio of the weights between the player and the object. For example, it's easier to throw a frisbee faster than a paper plate because a frisbee weighs more. So now you understand the invariant features of a generalized motor program, which are the components of a skill that cannot be changed. Let's look at certain parameters that can be changed. The first parameter I'd like to discuss is the overall force. Not every player applies the same overall force to every throw. Sometimes this is because you want the disc to land in a certain area, so you wouldn't apply as much force. I gave an example from the Monthubert and Sarah Hummel study, which shows the different joint and muscle activations for putting work into throwing the frisbee. So you can see work in the positive and work in the negative. And so work in the positive means that the player is applying force downrange, whereas for instance, the elbow flexion is the player is applying negative work because it's the wind up, which is moving away from downrange. The second parameter I'd like to discuss is muscle selection. I'm using the example again from the study because the example I'm going to use is the wrist flexion force. A lot of professional players will put more work into their wrist to get a higher spin rate, and this creates a ideal lift drag ratio. Discuss is direction. So you can see in the first video I hit the power pole, and in the second I go right between them. In conclusion, the motor program required for throwing a frisbee can be practiced, and all the parameters that were explained can be manipulated by a player to achieve a greater distance or put the frisbee onto a certain location within the field.